Hi, in this video we'll be looking at arguments. In discrete mathematics, an argument is a sequence of propositions known as the premise followed by another proposition that is known as the conclusion. Now, in this video we're going to determine when an argument is said to be valid. So here we have the argument: if I work, then I can't study. Either I work or I pass discrete math. I passed the discrete math, therefore I studied. So we'll start by identifying our premise first. So the last statement, usually the one that comes after the therefore, is our conclusion. So this here is our conclusion. And these other guys here forms our premise. Now what we're going to do is we're going to write this. So we have it in words. So we're going to write it symbolically. So what we will do is we'll assign variables to the different statements. So here we have a conditional statement. So if I work, then I can't study. So the two statements here is if I work is I work, so we call this P. And next one is I can't study, so we call this one Q. In this line here, we have either I work or I pass discrete math. So here we have a disjunction. So we have I work, which we already established to be P. So that's P. Or I pass discrete math, so this is a new one, so let's call this R. Here we have I passed discrete math, which is R, so we call this R. Therefore I studied. We didn't have this exactly, I studied. We have I can't study. So this would be the negation of this guy here, or it's the opposite of this guy here, so it's a negation. So this is just negation Q. So this looks a bit confusing. So what we'll do is let's write it now symbolically. So what this is saying is if I work, then I can't study. So we had established that this is a conditional statement. So this is just P implies Q. Because remember, P is the statement I work and Q is the statement I can't study. Either I work or I pass discrete math. So this is the disjunction. So we have P or R. I pass discrete math, which is R. Therefore, I studied. So that's our conclusion. So it's negation Q. So symbolically, this argument would be represented with these statements. Alright? Now we need to determine if the argument is valid. So what we're going to do is we're going to turn our attention to our truth table. So we need to represent all of these statements in the truth table. Alright? Now we need P implies Q. We need P or R. We need R, and we need negation Q. So P implies Q, and remember for the conditional statement, this is only false, or this will only be false when P is true and Q is false. So P implies Q, so we have this is true, true, false, false, true, 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 true. For P or R, remember with the disjunction, this is only false when both P and R are false. So P or R, so this will be true, 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 F, true, false. For R, we just write back what was R. So true, false, true, false, true, false, true, false. Now, all of these here, so this formed our premise. So here is our premise. Now what we're going to do is we are going to focus only on the rows that all the premises are true. So for example, here, and we call these critical rows. So this is critical row 1. We have another one here. Call this critical row 2. We have another one here, which is critical row 3. Now we examine the truth value for each of these critical rows. So negation Q, Q was true, so this will be false. Negation Q, Q was true, so once again this will be false. Negation Q, this was false, so this will be true. Now, since for a critical row we have a false conclusion, then we would say that our argument is not valid. The only time our argument is valid is unless all our critical rows have a true conclusion. So therefore we would say, so since, and we just need one example. So since critical row 1 has a false conclusion, the argument is not valid.